All right, algebra 2, here we go. 7.2. Okay, properties of exponential functions. Okay, remember 7.1 we talked about growth and decay. So now we're going to look at the graphs of it. What about the transformations of exponential functions? Okay, how do we translate? How do we move the graph? Just like we've been doing. Absolute value quadratics. We moved the square roots, the cube roots. Now we're just moving the exponentials. Okay, we know that decay is going up to the right, or I'm sorry, growth is going up to the right, decay is going down to the right. The thing here is we move from A, where we cross that y-axis. That's going to be our point, not the origin, because remember we don't actually touch the y equals 0 or the x-axis. So we're going to move from our A value, whatever it is right here. You're going to go right or left opposite with whatever is being added or subtracted from the x, your exponent up here. If something's added or subtracted upside, we're going to move up or down. So if you look at the example y equals 2 to the x minus 4, your A value is 1, and we've got x minus 4, so we're going to move opposite. We're going to go 4 to the right. So from A is 1 right here, we're going to move over 4 places, 1, 2, 3, 4. So that's our spot, and then I'm just going to draw in my growth because my B is bigger than 1. So yeah, I'm going to get exponential growth. I'm just going to rough that in there. Remember, the x-axis, y equal to 0 is an asymptote, so we're not going to touch that line. Get ever so close to it. Go through our point and then go up because it's decay. What about this example? Graph y equals negative 1/3 times 1/2 to the x plus 2 power. Okay? So my B is 1/2, so I know I'm going to get decay. Okay? But I've got a negative 1/3 for my A value. So not only I'm going to cross at negative 1/3, but because it's negative, I'm on the downside. Remember, I can't touch the x-axis. I reflect down. Okay? Remember, this graph would do this. That's decay. So, like I showed you over here. So, its reflection down here, because the negative A, would look like this. Okay? So that's what I did here. I went down about 1/3. I'm going to go 2 places to the left, 1, 2. So there's my point right there. And I'm going to reflect my decay. So there's my graph right there. Y equal to 0, the x-axis is still an asymptote. We can't touch it. Okay? So very similar to what we've been doing. Just pay attention to what it is so you know what kind of line you're going to draw in there. Okay? Well, where do we use this stuff at? Here's another example here. But now we're talking about base E. Remember, base is what you're raising, the number that's being raised to your power, and since your exponent, t in this case, okay, so your base is E. E is like pi. It has a value, okay? But rather than write out 2.71828, that's E, all the time, just like we don't always write out 3.14, we just put pi in there, we know what it is, okay? That's what E is right there. Now some of your calculators have it in it. If you look, and it may be on, on top of one of the keys, right above it. So look for it. If not, then you know it's 2.71828. Okay, that's that number right there that's being raised to a power. This is the formula for continuously compounded interest. Okay, simple interest at the end of 1 year. Boom, they figure out the interest, they add it to your account, and now you got a new balance. Okay, you start compounding. They can start doing things like every 6 months, compound semi-annually, compound quarterly, every 3 months. They'll figure out your interest, add it to it, and you get a new balance. Here we're just looking at continually compounded. It's almost like a daily thing. So the amount over time is equal to the principal, what you put into it, times your E, this number right here, raised to the RT power, where R is the rate as a decimal and T is your time in years. Okay? So if you deposited $3,000 at 5% for 4 years, how much money would you have in there at the end of 4 years? Well, the amount after 4 years, they have 4, would be 3,000, my principal, times e to the 0.05, there's my rate as a decimal, times my time, 4. 0.05 times 4 is 0.2. E to the 0.2 power times 3,000 is $3,664. That's what you would have in your account after 4 years, if it's compounded continuously. Okay? So there's another example of it. There's E right there. Make sure you get that down in the notes because you're going to use that here in the homework. And we'll look at some more of this stuff here. This is good stuff because you actually use this stuff, especially if you're in the business field. Okay? All right, we'll get after that tomorrow. See you then. Bye.